Lesson 3-4 is about scientific notation. We're getting scientific with it today. So basically, scientific notation is a way to draw really long or large numbers, or a way to write really large numbers in an easier way. For example, if I was going to write down the number of ants there were on planet Earth, there's an intense amount of ants on planet Earth, especially in the jungle. And if I said that there were 9,800,000,000,000 ants on planet Earth, I would write that out, 9,800,000,000,000, and that's what that would look like. Because this is the ones up to hundreds, thousands, millions, billions, trillions. And that takes up a lot of space. And so if we're just going to talk about that, we would say, well, 9.8 trillion. And how we would write out that number in scientific notation would be 9.8 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12th power. And I'm going to show you how to do that by the end of this lesson. Really, all scientific notation is a way to represent huge numbers easier. And a couple things from this lesson are going to be really important to learn, or to help you in math, about dealing with tens. Because tens are something that you should be able to deal with in a really, really easy way. And sometimes we waste our time writing out these problems that would have to do with tens, and it's really unnecessary. And I'm going to show you that, and that kind of goes along with this lesson. So, the first thing that you need to know is that when you do scientific notation, what you're doing is multiplying by by tens. So, when you have a number, for example, like 4.1 times 10, all we're doing here is 4.1 times 10. Now, when you do a problem like that, all you're going to do always is you're going to get 0 first, because there's a 0 right there. It's always going to be 0. And then you're going to put your placeholder 0, and since it's by 1 in the other one, all you're going to do is write it in. And so then your answer is going to end up, and there's one decimal, your answer is going to be at 41. So you go from 4.1 to 41. And so the numbers don't change. The only thing that changes is where the decimal is. You see, since we multiplied by 10, all we did was move the decimal 1 to the right to get 41. And that's the important thing that you need to realize. Now, 10 to the second power, if we're just going to look at that like that, 10 to the second power, we know because of our exponents that means 10 times 10. And again, if we take 10 and we multiply it times 10, what did I just show you? We could do it like this, and we get 0, and then we get 0 in our placeholder, and so our answer is going to end up being 100. But every time you multiply by a power of 10, all you do is you move the decimal. And so a way to represent those numbers, for example, 10 to the first power would just be 10. 10 to the second power would be 100. 10 to the third power would be 1,000. And one way, a little cheat sheet, is you notice to the first power there's 1 0. To the second power there's 2 zeros after the 1. To the third power there is 3 zeros. So 10 to the fourth power would be how many zeros? 1, 2, 3, 4. So as you can imagine, if we kept going, for example, if we did 10 to the 9 power, we would have a 1 with 9 zeros after it. And so we can take that knowledge in addition to how we multiply by tens. So if we looked at 4.1 times 10 to the first, that would mean 4.1 times 10. And we know that all we're going to end up doing is moving the decimal 1 when we multiply it by 10. So then, remember, 10 to the second power would be 100, because it's a 10 with 2 zeros. So if we multiply by 4.1 times 10 to the second power, what we're doing is, all we're going to do is move the decimal, however many zeros there are. and which is also the same as whatever your exponent is on 10. So 4.1 times 10 to the second, I know all I'm going to have to do is move the decimal 2 spots. Now, since I'm moving in 2 spots and there's nothing there, we have to put a placeholder. So 4.1 times 10 to the second would be 410. So a quick way to remember that is if we take a number like times 3.5 and we multiply it by a power of 10. Well, if we multiply it by 10, that would be the same as 3.5 times 10 to the first. 3.5 times 100 would be the same as 3.5 times 10 to the second. And since we know all we do is move the decimal however many zeros there are in the 10 number, we can take a look at, for example, 3.5 times 10 to the fifth. We know that all we're going to do is move that decimal 5 times. So what that number really is 350,000. So let's practice one. Let's do, for example, 9.2 times 10 to the fifth. Pause and try and solve that. Okay, so like I said, it says 10 to the fifth power. So all that means is we're going to move this decimal 10 places. So 5 places. 1, 2, 3, 4, 5. And then, since we don't have anything there, we're going to put in zeros, and the decimal goes at the end. So our answer would be 920,000. Try one more. 3.67 times 10 to the fourth. So all that means is we're going to move it 4 places. So 3.67, then we're going to move it 4 places. 1, 2, 3, 4. Put your zeros in. So our answer would be, with the comment, 36,700. Now the other thing that we will be doing is going the opposite way. So if we have a number like 356,000, we want to put that into scientific notation, we have to go backwards. So what we always do with scientific notation is we have to put the decimal in between the first 2 numbers, right there. And we're going to make it into a decimal. So we're going to change 356,000. We're going to put the decimal there, 3.56. And all the zeros, since it's a decimal, we don't have to put the zeros after, because 3.56 is the same as 3.56 with 3 zeros. And that's just a waste of our time. So we're just going to put 3.56 and ignore all the rest of the zeros afterwards. And so that's what our number is going to be. And then we're going to have to take it times 10 to a certain power. And in order to find out which power it is, you look at where is the decimal and where did you change the decimal to. And then we're going to count how many spaces you had to move it. So 1, 2, 3, 4, 5. So our answer is 3.56 times 10 to the fifth. Let's do another one like that. So let's look at Nebraska's, with the new renovations, Memorial Stadium holds 92,000 people. I want you to pause and I want you to put that into scientific notation. Okay, so what you first do is you change your decimal. It has to go in between the first 2 numbers. So it's going to be 9.2, and there'd be 3 zeros after, but we don't have to put those in. And then it's going to be times 10 to what power? So let's look. The decimal was right here at the end. 1, 2, 3, 4. We moved it 4 places, so it's going to be times 10 to the fourth. So our answer is 9.2 times 10 to the fourth. So the important thing to talk about with all of this lesson is that when you multiply by 10, 100, any of these powers of 10, all you really have to do is move the decimal however many places your value of 10 is. So for example, if we took 3.6 times 1,000, I see so many times students will go through and they'll do the whole problem. They'll go 0, 0, and do all that. Well, that's just a waste of time. All you have to do is look at how many zeros there are and move the decimal. So 3.6 times 1,000, all you're going to need to do is move it 1, 2, 3 spots. So we're going to go 1, 2, 3, So my answer would be 3,600. And the opposite goes when you divide. If you take, for example, 952 divided by 1,000, since you're dividing, we're going to go the opposite way with the decimal. So right now the decimal is right there, so it's 1, 2, 3, so all we're going to do is 1, 2, 3. So our answer would be 0.952, or 952 thousandths. So that's a tip that's going to save you a lot of time on your math in general. Whenever you see a multiple, or whenever you see a power of 10, all you need to do is move the decimal. So if you have 952 times 1,000, all we have to do is move that decimal 1, 2, 3 places. So we get 952,000. Save yourself time on that, please, because it takes a long time to go through those problems in this way. And you just don't even need to bother. So, I'm going to have you do one problem that you need to solve for tomorrow. I should say one problem going each way. So, if I eat 92,000, I already used the number 92,000. Hold on. Anyways, I'm going to eat more than that. If I, let's see, 150,000 burritos in my life, I want you to put that into scientific notation. And then, I want you to determine what is 3.97 times 10 to the 6th power. I want you to put that in standard, which means just normal. So those are the two problems I want you to have solved for tomorrow. See you tomorrow.